Now let us resume with solving these problems involving equations of lines. We left off at number 10 in the previous video. Now we come down here, number 11, the x and y intercepts. Of course, the y-intercept is right there, obvious, nothing to do. The x-intercept is occurring when y equals 0, so if we let y equal 0, you get a little equation from which we can solve for x, revealing that the x-intercept is 7.5, okay? Number 12, this goes back to remembering that in the standard form, the slope is the opposite of a over b, so the slope here can be identified as, and that's right here, the slope can be identified as -3 over k, but you're told it's equal to 4, so you cross multiply and solve for k as -3/4. Although it's a distance problem, you can get away without the distance formula because these 2 points are on a vertical line. So simply account the number of units between 7 and -3, which is of course 10. 14 is pivotal upon you knowing your 3, 4, 5 right triangles. Okay, and of course you could use the distance formula. It wouldn't be that much work, but a couple seconds can be saved by realizing the 3, 4, 5 triangle so that this distance is 5 units. Okay, midpoint, that's certainly a simple question. I shouldn't have any problem with that. Okay, number 16 is very much like number 6. It's not the same problem, I think, from number 6, so that I don't need to reference. 17. So the equation of a line parallel, so if it's paralleling, it has the same slope. In this form, we know the slope is 2/5, and we know we got to go through 8, 5. So we use the modified point slope form. Y minus 5 over x minus 8 is equal to the slope. Cross multiply, okay, and it doesn't take a whole lot of work to get it to the standard form. Of course, cross multiplying 3y minus 15 equals 2x. 2x, what is that? 2x minus 16. And then add 15 to both sides, scoot the 2x over, and I factored out the negative. 18. The equation of a line passing through this point and perpendicular to the line through these points. Well, then this means as follows. Okay, you have these 2 points, and then you have a line, a point. These 2 points which form in a segment, and then a point up here, and that point needs to draw a perpendicular bisector to. Well, it doesn't need to draw the perpendicular bisector. Okay, it just needs it through that. Okay, so we need the slope, so we need the slope of the line through these 2 points boxed out. Okay, so that slope is 5, regular slope formula, 5 minus 3 over -2 minus 4. That ends up being a -1/3 slope. Its perpendicular would be 3. Now, okay, so now we have the slope of the new line we want, and we know what point it needs to go through. And I just use the point slope form because this doesn't have a fraction as a slope, so I could easily distribute. You could leave it at that. Doesn't take a whole lot of effort to make solve this for y, which would be what y equals 3x, and this distribute would be minus 6, and plus 1 would make it minus 5. Okay. 19 is a perpendicular bisector, and I addressed a problem like that in one of the previous videos, and you should go back and look at that. And of course, with that, then you have to remember this is a segment. You want the slope of that segment. Then you take its negative reciprocal because you want the perpendicular slope. And then you want the midpoint of that segment because that segment's to be bisected. So you want the line which goes through the midpoint of the segment containing these two, and whose slope is the negative reciprocal of the slope through those two. Number 20 kind of reference you back to that same kind of problem. 21 is the most interesting problem. Let's outline that for you. Okay, so there's some segment that, or some line has a slope of negative 3/4, and it crosses the axes and makes a triangle in here between the x and y axes, whose area is 24. So we are after the equation of that line. So if it's going through the axes, I'm going to arbitrarily label the points where it crosses the axes. So it crosses the y-axis here, okay, at some location B on the y-axis, which is, of course, having coordinate 0b. And likewise over here on the x-axis crossing, where its coordinates will be a0. Now, as a triangle, we know the dimensions of this triangle are b by a. And so therefore, the area of the triangle is 1/2 the product of b and a. So 1/2 product b/a is 24, which is to say ab equals 48. Now, what's the slope between these two? Well, using those coordinates and the slope formula, you have b minus 0 over 0 minus a, negative a. So the slope is b over negative a. All right? But we also know that that slope from this line is negative 3/4. So if we equate this slope with the slope of negative 3/4 and we cross multiply, we get that b is equal to 3/4 a. And b is equal to 3/4 a. But coming back over here, we can say that b is equal to 48 over a, and therefore replace that back into this equation, and now we have an equation in a. So if we cross multiply, that comes up to it goes from here, comes up here, so we get a squared is 4/3 of 48, so a is going to be equal 8. If a is 8 and a times b is 48, b is 6. Having that, now we have the equation, we have the y-intercept, or the equation of the line.